What is up, everyone? As you guys know, new questions have been added to the question bank. Specifically, 270 questions, right? When you have math and English combined. And this video is going to be the third video in the series where we're just covering everything in the math section of the question bank, right? So in the first two videos, we have looked at the domains algebra and also the advanced math, right? And what we're planning to do in today's video is look at the problem solving and data analysis domain, right? Which is going to be statistics, right? Mostly. And we're gonna have one more remaining video within the series, right? And that's gonna be geometry, the largest section there, right? In the new question bank, we had like 50 questions, I believe, just for the geometry section, right? While others have much less questions there, right? And yeah, we're gonna be basically walking through the problem solving and data analysis domain of the math section of the new question bank in 2026 August, right? And yeah. And as you guys can see, I personally got a 1600 on my SAT in 2025, right? And I'm gonna be showing you guys how to solve, how to approach these questions, and the quickest ways, and also how to apply Desmos to statistics, right? When you have, for example, median, mean, standard deviation, maybe percentages. As you guys can see here, we have the first question is percentages, right? So I'm gonna be basically showing you guys how I, as a 1600 holder, would solve these questions. So I guess we could now at this point get started. So let's get started with the first question. A square scale drawing has a side length of 55 inches, and 1 inch on the drawing represents an actual distance of 19 miles. A larger version of the same drawing is printed as a square with a side length 56% longer than the side length of the previous drawing. On the larger drawing, which of the following is closest to the actual distance in miles represented by 1 inch? That's a lot of words here, right? So first of all, let's understand what's happening. We have a square scale drawing, right? So we have a square. It's a drawing, yeah. Oh, it's not working. Okay, and it has a side length of 55 inches, right? And then 1 inch just represents 19 miles in the actual distance, right? It's just a drawing, right? It's like scaled, right? So the actual distance is much actually higher, right? Specifically, how much is it? The distance, right? It's gonna be just 55 inches. Each inch represents 19 miles, so you're gonna multiply by 19 to get the actual distance there, right? So 55 inches, they encompass how much distance? So it's gonna be 55 times 19. And we get that it's gonna be 1,045 miles in reality, right? And then we have the same drawing, but now it's gonna be a little bit larger scale, right? So it's gonna be something like that. And now the distance is no longer 55 inches. It is 65% longer, right? So it's gonna be 55. And because it's 65 inches, 65% longer, it's gonna be 1.65, right? Where did I get this value? Where did I derive it from? It is basically 100%, and then you're increasing it by 65%, so it's gonna be 165%. And when you convert it to just decimal value, it's gonna be 1.65, right? So now the actual distance, the new distance on the map, it's going to be 90.75 miles, inches, right? On the larger drawing, which of the following is closest to the actual distance in miles represented by 1 inch? So even though the map is larger here, how much distance it is representing in real life, it is still the same, right? It's still gonna be 1045 miles, right? So 90.75 inches in total representing this many miles. So 1 inch representing how much? You can do proportion or you can just divide, right? So it's gonna be 145 over 90.75, and that's gonna be the answer to the first question. 145 over 90.75. It's 90, right? So it's gonna be 1152 rounded up, right? So it's gonna be option B in this question. It is quite a bit of difficult question. Difficulty level is 3, as you guys can see, right? So 1 inch is now representing a less distance than 55. It makes sense that it's gonna be less when you really think about it, right? So the answer here, it is going to be 11.52. Now moving on to the next question. Researchers studied a sample of species of fish from a certain location. The researchers found that the mean length of fish in the sample was 16.59 millimeters. Based on the sample mean and the margin of error, the researchers estimated that the mean length of all fish of the species from this location was between this to that millimeters. What is the margin of error in millimeters? So you have 16.59 in your sample, right? But then your sample suggests that the mean weight of the species, right? It's gonna be 16.59, but when you're generalizing it to the whole population, not just sample now, right? You're gonna introduce this margin of error idea, right? So it's just gonna add once, it's gonna subtract once, right? So when you add this margin of error, let's call it X for now, it should be now the larger boundary, which is gonna be 17.32. But at the same time, when you subtract this margin of error, it should come down to 15.86. It should be the same value, so just take one of those equations there and just solve for it, right? So it's gonna be 16.59 plus x1, I'm gonna call it, so that I'm not gonna look for it, 17.32. I'm not gonna be basically looking for it, the axis there, right? So I see that the margin of error is gonna be 0.73, right? It also makes sense when you subtract it, for example. Let me show you guys. So you have 16.59, and when you subtract this 0.73 there, you're gonna come down to this value. Same thing, right? So that's how we solve the second question. Now moving on to the third question. For dataset A, the table summarizes the distribution of the number of deliveries received by an office each day during a period of 11 days. Now, as you guys can see, in 2 days we had no deliveries. In 2 days we had 3 deliveries, right? And it goes on. As the data value of 13 was recorded in error and is removed from the dataset A to create dataset B, right? So dataset A was basically 0, 0, 3, 3, 4, 4, 5, 5, 6, 7, 13. In total, how many do I have? It should come down to 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, everything's correct. And then we're just removing the 13 to see what happens, right? And then which statement best compares the median of dataset A and median of dataset B. So we're comparing the median. If I had to guess before looking at the options, it would probably be equal. The median does not change, because the median from like statistics, when you really go into statistics, like median is like a resistant measurement, right? It's a center measurement. But let's see. So beforehand, when I had this values there, right? So I had 11 values. So the median, first of all, is it in order? Yes, it is. So we can find just the centers there, right? When you have 11 values, it's going to be the center is 11 plus 1 over 2, which is going to be 6. So when you have certain number of values there, to find the center, you're going to be applying this formula, n plus 1 over 2. You really want to know it, especially when you have really large number of numbers there, number of values. When you have, for example, 56 values, which is going to be the center, you're going to be applying this formula, right? So when you have 11 values, the center is going to be 6 values, so it's going to be 1, 2, 3, 4, 5, 6, so it comes down to 4. So previously, it was 4. But now, new one, what happens? When you subtract this, when you remove the 13, you now have in total 10 values. That means the center is now going to change. It's going to be 10 plus 1 over 2. It's going to be 5.5. Which means you're going to be just taking the 5th and 6th value and finds their mean, or finds their average, right? So 1, 2, 3, 4, 5, and 6, right? 5, 1, 2, 3, 4, 5, and 6, yeah. So 5.5 it came down to 5, yeah, everything's correct. So it's gonna be 4 plus 4 over 2, right? 4 plus 4 over 2. So 5th value, the 6th value over 2, right? So it just comes down to, again, 4. So yeah, my guess was right. They're equal. So it's gonna be option C here. But it's not always the case. Even when you remove outliers, median sometimes changes, right? It's like when it changes, basically it doesn't change by a whole lot, as in the case of mean, right? So it doesn't necessarily mean that median never changes, right? Don't take that as the statement, right? It's just it was a guess, right? Now moving on to the next question. which is the following. Lists represents a data set with a small standard deviation. Now, in the case you guys don't know what is standard deviation, basically what standard deviation does is it just measures a spread. I would just say spread, right? You have a formula to it. You don't have to know. If you really want to calculate it, actually you can calculate it on Desmos, right? I'm gonna be showing that. Basically, it just shows how much each value is away from the mean on average, right? For example, one value is away from the mean by 2. One value is away from the mean by 4. So the average distance would be 3, right? So that's, you can use that 3 as standard deviation, right? So standard deviation basically represents how much spread or how much the values are close to each other, right? So you want to show these small standard deviations there. So it's gonna be, if you look at all of the options there, option D, right? So I'd like to make a dot plot for that, like in my imagination, right? So 51, right? 52, 54, 56, right? And 57. Have this 52, 52, 56, 56, and 54 there. So I have 2 points, 1 point there. I'm not gonna draw it, but you guys can imagine. 52, 53, 54, 55, 56, and then I have 53, 54, 54, 54, and 55, yeah? So it's like, it's gonna be like this. It is the closest of them all, right? The values there. So it's gonna be option D here, right? So the values there, they're the closest to each other of all the values in options there, right? If you are not sure, you can actually utilize Desmos here. How do we do that? In the statistics section, we have STDEV, right? It's a standard deviation. So you're going to press that. Let's check option A. 51, 51, right? And 52, 54, 56, and 57. So it comes down to around 2.55, yeah? Option B, we're gonna check. So you're gonna have 52 here, 52 here, 52, 52, 54, 56, and 56. It's gonna be better than option A, right? Because it's closer. Oh, it comes down to a perfect value. I mean, integer value. And then you have option C. You have 52, you have 52, you have 53, you have 54. It's a bit spread. 55. So it's gonna, oh, it's actually better than option B. Oh yeah, because you have two distances there. Okay, so it's gonna be 1.58, and then the last option you have 53, so 53, and then you have 54 there, and 54 there, right? And then you have 55 in fact. So it's gonna be 0.707. It is indeed option D here, right? So you can think of it as being spread or not, or you can actually utilize Desmos if that's preferable. For me, I don't use Desmos here in such a question. But if I had time, I would just make sure that it is D just by checking our options. I mean, in Desmos, right? So let's move on to the next one. For 100 buttons, the table summarizes the distribution by group and diameter. So I have certain groups. Well, it could be groups in terms of its color. It's certain category you have, right? And then you have the diameter of it, right? How large or how small it is. One of these buttons will be selected at random. What is the probability of selecting a button with a diameter that is less than or equal to 30 millimeters, given that it is not group 2, I'm sorry. That's gonna be the biggest thing that you wanna pay attention to. Whenever you have given that or given, make sure that you're aware of what's happening there, right? Given that always changes the population, right? So we're saying that it is 100% that you're not choosing from group 2, right? Given that it's not gonna be group 2, what is the probability of selecting a button that is less than or equal to 30, right? So there's no chance that when you select one button, it's gonna be from group 2, yeah? It just basically means you removed all of the buttons of group 2 from this box there, and then you're randomly choosing, right? You can think of it that way. Just that given that always means it's not gonna happen, right? So given that the buttons that you choose will not be group 2, so you can cross out this possibility there, right? What is the probability of selecting a button with a diameter that is less than or equal to 30? So less than or equal to 30. So it's not gonna be greater than 30. It's gonna be from here to there, right? So what is the probabilities there? So I have, in total, how many do I have in total? In total, I have, 12 plus 8 plus 3, right? Because this group 2 is not there, plus 10 plus 32. So the population, as I said, changes. You don't have group 2 balance in the box. So it's gonna be this value, and what is gonna be the targets that we have, because in probability you have target and total. Well, the target is going to be, we want to have a diameter that's less than or equal to 30. So it's gonna be 12 plus 8, so 12 plus 8, but at the same time, 10 plus 32, right? You're just not gonna have a 3 there, and that's all. So now we're gonna have target over total, right? So it's gonna be 12 plus 8 plus 10 plus 32, 10 plus 32, all that divided by 12 plus 8 plus 3 plus 10, and plus 10 plus 32. So it's gonna be 62 over 65, and that would be my answer there, right? So what did I do? I just disregarded the group 2, so it's gonna be 12 plus 8 plus 3 plus 10 plus 32 plus 0, right? So it's gonna come down to this value. As I have, I believe it's gonna come down to 65 there. And the target is gonna be now less than or equal to 30, so 12 plus 8 plus 10 plus 32. That's it. So it's gonna be 62 over 65, right? Done. Yeah. Moving on to the next question. As the speeds of object A, B, and C are A meters per second, B meters per second, and C meters per second, respectively. If the speed of object A is 5900% of the speed of object C, so object A, the speed of it is 5900% of the speed of object C, right? So it becomes 59C basically, because when you convert to 5900, it just converts to 59. You just divide by 100, right? I guess you guys know it. Okay. And then the object C, the speed of object C is going to be 0.008% of object C. So how we write it is we have 0.008% of object B, right? It's going to be option B. And then the thing is, it's still in percentage, right? We want to convert it to percentages. A lot of people forget it here. The fact that you need to actually divide by 100 before you multiply. You don't just multiply 0.008 by B. You divide it by 100 first. So it becomes that C is actually equal to 0.0020 and 8B. That's super small values there. Which expression represents the value of A plus C, B plus C, in terms of C? So A plus B, we want to know in terms of C. So instead of A, I'm going to plug in 59C. In terms of B, right, I want to express it in C as well. So it becomes that if C is equal to that, I can divide both sides by this value. So it becomes that B is equal to C over 0.00008. It becomes C over 0.2 O's and more 2 O's and B. Oh, that would be gone. I forgot that. So, yeah, that's gonna be it. So A plus B, it's gonna be, instead of A, we have 59C, instead of B, we have this, right? So it becomes 59 plus 1 over 0.4 zeros and 8. So it becomes 12,559 C. That's what A plus B is equal to. So I have an option D, right? Like digital to digital, every value is there. Moving on to the next question now. The scatter plot shows a relationship between the number of swans, Y, in a certain population and the number of years since 1970, where X is in between this and that. Okay, so it basically shows you the population of the swans, right? In its relationship with years. So as you can see, is that as years go by, the population is increasing, right? So what we were asked to find is to find the appropriate exponential model. So basically, we're asked for the best fit, right? The exponential best fit here. So yeah. It's gonna be super simple, guys. I can immediately cross out option A and option C there, because in the power I have negative x when the function is literally increasing, right? Negative x in the power would represent that you're actually decreasing there, right? Let me show you guys, for example, one of them, 49, 1.04 to the power of negative x. Do you see how it's just decreasing? So it's not gonna be option A or C, and we have option B and D left. Well, this value represents the initial value, and I can see that the initial value is actually 30 something, right? Or 40 something, because it's in between 30 and 60. Option B makes sense, option D does not. So it's gonna be option B. Now, moving on to the next question, a group of 10 botanists recorded data on the germination rates of a certain type of seed for one growing season. The scatter plot shows a relationship between the number of seeds planted, X, and the number of seeds that germinated, Y, for each of the botanists. A line of best fit is also shown. So, what X represents here, I want to write it down, is the number of seeds planted. Number of seeds planted. And then Y represents the number of seeds that germinate. Germinate just means when you plant a seed, it doesn't always grow, right? Sometimes it does, sometimes it does not. So the germination is what we call the plant growing out, right? So the seeds germinated. Number of seeds germinated. Okay, I have this relationship here. Yeah, it does make sense. The more you plant seeds, the more germination you're gonna get. It's simple as that, right? Yeah, we do have a positive relationship here. No other it wouldn't make sense to have negative or no correlation here, right? Which is the following is the best interpretation of the slope of the line. Okay, so the slope, what it means, right? First of all, before calculating the slope, okay, let's first of all calculate the slope. For example, I know this point for sure, it's gonna be 252, it corresponds to 150 there. What else do I know? I know that 0, 0, right? 0, 0, around 0, 0, right? So it's gonna be, the slope is gonna be 150 minus 0 over 250 minus 0. So it becomes 15 over 25. When you even simplify that, you're gonna get 3 over, or actually, I have 60 and 100 here, so let me actually make it in 100, right? So it's gonna be, I'm gonna multiply both sides by 4, so it's gonna be 60 over 100. So the slope is 60 over 100, right? What is this interpretation of that, right? Well, before reading these options, let me guess it here. So the X again represents the number of seeds that you planted. Y represents the numbers that germinated. So the slope, it just means for every 100 plants, seeds planted, 60 is gonna germinate. 100 planted, 60 germinate. 100 planted, 60 germinate, right? That's the interpretation set, right? So the number of seeds planted is predicted to increase by 60 seeds every 100 days. Where did the measurement of days even come from? I mean, we just have two variables here. The number of seeds planted and the germinated. We don't know the correlation in terms of days. The number of seeds planted is predicted to increase by 300 every 100 days. No, every 100 days it's gonna be 60. Yeah. As the number of seeds that germinate is predicted to increase by 60 seeds for every additional 100 seeds that are planted. Oh yeah. Every time, like every 100 seeds, 60 seeds will germinate. So the probability of your plant germinating is gonna be like 0.6 every time, right? The number of seeds that germinate is predicted to increase by 300. I don't know where they're getting the 300 there, right? Let's move on to the next question then. We have this. On average, a certain plant grows 87 millimeters every m months. At this rate, which expression represents the number of millimeters on average a plant grows every k years? This is a stupid question. I really hate this question. I believe this question was in the previous question bank as well. I don't think it's a new question there. But yeah, I really hate it. So how do we go about these questions there? It's quite difficult, I would say. So you have this plant, right? It grows by 87 millimeters every certain months, every 2 months, every 3 months, every 1 month, every 6 months. We don't know. That's what M is, right? M is gonna determine how much it will increase. Like in what period it's gonna increase by 87 millimeters, right? Maybe in 1 year, maybe in 2 months, right? It's gonna be something like that. So the average grows, then becomes 87 over m. Think about it. If you increase by 87 millimeters in 2 months, you're gonna just divide 87 by 2. If you increase by 87 every 6 months, you're gonna divide it by 6 to get 1 month's increase. If you have an increase of 87 in 1 month, you're gonna divide by 1, or just nothing's there. Yeah. So yeah, this expression here gives the average increase per month. And then at this rate, which expression represents the number of millimeters on average the plant grows every year? Now you want to talk about how much it grows in certain years, certain amount of years, maybe in 1 year, in maybe 2 years, in maybe 3 years, right? So yeah, this expression gives you how much it increases by in 1 month, right? And then k years in months, it's gonna be 12 times k months. You want to think about it, because 1 year, if you assume that k is 1, then it's gonna be 12 months, right? So when k is 1, you should get 12 months. When k is 2, you should get 24 months, right? How are we doing it? We're just multiplying k by 12, right? So k years, it's the same as saying 12 times k months, right? So in 1 month, if it's increasing by this much, in k years or in 12 times k months, it's gonna increase by this much, right? So it becomes here one of the options here, D, 1044 k over m. So this expression is gonna give you how much the plant will increase by on average every k years, right? So the hard way of going through this question is gonna be this, where you have 87 over m, which gives you the average increase in 1 month, and then you're gonna convert it to the years, right? You're gonna basically multiply by 12 to get 12k to get the every k year increase there, right? So it's gonna be option actually D here, right? Super difficult when you're doing it for the first time. But how else could we have approached this question? Is we could have approached it super easily by giving m and k fixed values, right? First of all, imagine that tree grows by 87 millimeters every month, right? So m is gonna be 1. In such a case, and then you're gonna plug in case 1, imagine, right? So after 1 year, you should increase by, so 87 times 12, right? So you should increase by 1044, right? Again, imagine you're increasing by 87 millimeters every month, but now after 2 years, how much you're gonna increase? I mean, in 2 years of time, right? How much you're gonna increase? So it's gonna be, you're increasing by 87 millimeters per month. You're multiplying by 12 to get 1 year, and you're multiplied by 2. So you should increase by this much, right? And then option A, when you plug in this values, for example, you should get this, right? M is 1, K is 1, you're gonna get 29 over 4. Option B, 29 over 4. Option C, I get it. Option D, I get it. So both are potentials. But then I check the second point here, when K is 2, it should be 2088. So it's gonna rule out option C as well, which means we will be left with option D only. Moving on to the next question. A rectangle has an area of this square inches. What is the area in square feet of this rectangle? So the area of this rectangle is given in a square inches unit, right? But then you want to convert it to the square feet, right? So 3168 inches squared. Whenever I'm asked to convert it, I always multiply this value by 1. Does it change anything? No, right? Yeah, exactly. It doesn't change anything. So specifically, what I do is, because I know that 1 foot is just equal to 12 inches, right? I'm going to say 1 foot over 12 inches. First of all, let me explain this thing. When 1 foot is equal to 12 inches, so when I divide two things that are equal to each other, I'm going to get 1. So basically what I'm doing is I'm multiplying this inches squared, this area, by 1. Does it change anything again? Nothing changes, right? When you multiply this by 1, nothing changes. But then I specifically divide foot over inches and not inches over foot, even though that version would also result in a 1, is because I want the inches to cancel, right? Because inches here is the numerator, I want it in the denominator when I'm multiplying by 1. This golden 1, right? As I call it. And yeah. But then it's not gonna be enough, so let me multiply it by 1 once again, or just square it if you want. It's gonna be 1 foot over 12 inches. It's gonna always, or no matter what question it is, conversion, you can always apply. So then this inch cancels with inch squared, so you're gonna be left with 3168 over 12 times 12 feet squared, right? So now let me do it on Desmos here. It's gonna be 12 squared. I'll be left with 22, option A, right? So that's how we solve this question. Moving on to the next. A researcher is designing a study to investigate the average number of hours participants in a training course spend on a particular activity per day. Okay, the researcher will report an estimated average number of hours participants in a training course spend on this activity per day with an associated margin of error. Makes sense. The researcher is considering using a random sample of either 115 or 230, so double participants from the training course, which is a following would be most likely the effect of using larger random sample compared to small random sample. So when you have larger sample size, it's always for the good, right? Larger is better. Larger is better, always. So you want something positive there, right? The reported margin of error would be lower. Yeah, I would agree. Because the thing is, margin of error and then sample size, there's a negative correlation between them. Margin of error, sample size. As sample size gets better and better, as it gets larger, the margin of error will get lower. You can think of it that way. When you have a larger sample size, it just means you have more data. More data means you are less likely to get a mistake, right? Your error probability will be smaller, right? Because you have incorporated larger data, right? The more data, the less error. The more data, the less error. The less data, the more error. That's it, right? So yeah, I would choose option A. B, margin of error would be larger. No. You want to talk about using larger sample compared to small sample. Larger, when you use larger, margin of error will be smaller. Yeah, I understood. If it was opposite, then it would be option B. The reported average number of hours would be lower. No, you don't know. The reported average number of hours would be higher. You don't know what the mean is gonna be. Not based on the sample size. Next question. The table shows the distribution of rooms in a certain facility by seating capacity. So you have like 26% of all the rooms have less than 18 seats. 21% of all the rooms have 18 to 40 and goes on. The interpretation is there, right? If a room in this facility is selected at random, which of the following is closer to the probability of selecting a room that has a seating capacity greater than 65 seats, given that the room has a capacity of at least 18 seats? You see, again, we're seeing givens out. Yeah, it's gonna be super important, just as in the previous question. It means you're not choosing from rooms that are less than 18, right? You're excluding them. So exclusion, we have exclusion. So it's gonna be out, and then you wanna find out the probability of this, right? First of all, let's assume there were 100 rooms in this certain facility, right? So if you have in total 100 rooms, it's gonna be that 26 of them have less than 18, 21 have less in between 18 to 40, 29 is this many, 24 is this many, and then you're excluding this many, right? So now the population becomes 21, 29, 24, which will result in 21 plus 21 plus 29 plus 24. It's going to result in 74. So in total, you have 74 rooms now, not 100, because you have excluded 26. Oh, I should have just subtracted this there. Now the target becomes you want to choose 65 at least, right? So it's just going to be 24. So it's going to be 24 over 74, which will be 0.32, which is option B here, right? So that's how we solve this particular question. Yeah. Moving on to the next question. A researcher surveyed a random sample of this many people from a certain city to estimate the percentage of people who support a recently announced proposal. From the surveys, the researchers estimated that 86% of people from the city support this proposal with an associated margin of error of this. The researcher repeated the survey with a random sample of people from the city that was double the original sample size. Oh, see, sample size is now you have conducted one research, one study where you had this many people. Now, second time you have this many people, right? It's the same approach there, right? Again, random sample size, random sample from the same city, right? Assuming the margin of error were calculated in the same way, which is following is true about the margin of error associated with the estimate from the larger sample. So in the larger sample, your margin of error will be lower. It will be lower than 2.13, right? So it's gonna be option D straight away. Yeah? Because as I said, the more data you have, the less margin of error you have. Because margin of error is basically how much error you have, right? If you have less errors, that means you have less margin of error, right? That's it. The margin of error is in between this and that. No, it's gonna be less, for sure less. It's not gonna be higher. It's gonna be this and that higher, greater again, yeah. Only option D would make sense of all those options here. Next question, at a recreation center, visitors use the exercise room for a total of 3 hours in July. It's the same recreational center, visitors use the exercise room for this many hours in August. So in this recreational room, you have two facilities, exercise room you have, and then you have, oh wait. No. You have the same facility, you're using it in different times. For example, in July, you use it 3 hours, right? And then in August, you use it 3.49 times the exercise hours in previous months. What is the percent increase in the number of hours? Okay, so I see that in total you have 49% of the previous months. But don't just jump to the conclusion, oh, it's gonna be just option D there. No. It's not gonna be. It's gonna be actually 249%. Let me explain. Because what is the percent increase in the number of hours? So you had 3 hours, and then when you want to find the number of increase there, right? It's gonna be 1 plus P over 100, and then it's becoming 3.49 T. So these two T's cancel, and you get that P is 249, right? In August you are exercising 349% of the July, or you're exercising 249% higher than the number of hours that you exercised in July, right? So basically it's gonna be option C, right? You really want to be careful in terms of when you have percentage, either it's gonna be increase or decrease by, or it's gonna be off. So what is the percent from the previous month? It's gonna be 249%. What's the increase? It's gonna be 249%. You want to subtract this initial 100% out, right? So option C would make sense. What is the frequency of data value 2? So you have value 2 here. What is the frequency? Is going to be 6. Super easy, this one. We have easy questions, so good thing. As part of a study of lake conditions, the water temperature was recorded. I'm not gonna read that. Which of the following is closer to the slope of the line of best fit for the data shown? Okay, you want to talk about the slope here, right? So approximately, if I had to guess, it would go something like that, right? So what is the slope we have, right? And I have all of them are negative, so I cannot cross out any. And yeah, so we have to just guess, I guess. No, not guess, but like reasonably guess. Because we don't have specific points in which this line of best fit crosses, right? And we don't know the individual values, so if you really want to create the line of best fit on Desmos here, right? So yeah, we have to guess. So let's assume that as the initial value is somewhere here in between 20 and 25, right? Or can it be over 25? I don't think so. It's gonna be in between, most probably this. And then after 80, you're coming down to 10, around 10, right? So you increase by around 10, 15, 5. So if you increase by approximately 15 in a matter of around 80 depths, right? So it's gonna be negative 50. Oh, you decrease, I'm sorry, over 80, right? So it's gonna be 15 over 80, negative 18. Oh, option A. Wow, guess was really close. I was not expecting that. Yeah. The thing is, I can for sure cross out option C and D because they're too large. What C and D are saying is that when X increases by 1, y is decreasing by 6 or y is decreasing by 8. No. When x increased by 10, y barely decreased at all, right? Here, x increased from 0 to 10. 10 values in x border, right? Y decreased by what? Like 3, 4, right? It's not that much, yeah? So but option C and D, they say, oh, the y decreased by like 6, 8, right? So it's not gonna be one of them, I know that. But -2, maybe it's close. So when you increase by 10, it should be that the y decreased by 20. When x increases by 2, when x increases by 1, the y decreases by 2. When x increases by 10, y decreases by 20. When x increased by 10, y did not decrease by 20. I hope you guys understood it here. But yeah, it's gonna be option A, for sure. For sure, yeah. Next question, for a given data set, the data values are listed in ascending order. Ascending order just means lower to higher, right? You are ascending, right? Where A, B, and C are constant for this data set. The mean is 36, the median is 29, and the range is 72. Okay, so the range is 22, so that means C minus A should be 72. That's the first equation I have. The median, so I know the median. So how many values do you have? We don't know. Okay, we're gonna cross 1, 2, 3, 4, 6, 5. I know that B, the value of B, it is gonna be 29, is that right? And then the median, the mean is 36. So A plus 26 plus 29 plus B plus 31 plus 47 plus C all over by, how many values we have? 3, 3, 7. 7, it should be equal to 36, right? So then I will isolate for A plus B. So A plus B will be equal to, that's going to be 36 times 7 minus 26 minus 29 minus 31 minus 47. So A plus B is 119, yeah? So, oh wait, what? Wait, what did I do? 36 times 7 minus 26 minus 29 minus 31 minus 40. Oh, shoot. It's going to be A plus B plus C. A plus B plus C is 119. A, 26, 29, B, 31, 47, C, 7, 36, 36 times 7 minus 26, 29, 31, 47. Yeah. And then I will plug in 29 for B, so it becomes A plus 29 plus C is 119, right? That means A plus C will become 110 minus 20. It's gonna be 90, right? So C minus A is 72. I'm gonna do it by hand at this point because it even takes time to input those values. So 2C becomes 162. So C becomes 81. It's gonna be option C. Yeah. The last two questions we have. Yeah. A cluster fly is traveling at a velocity of 76 centimeters per second. What is the velocity in millimeters per second? Okay, so the velocity of speed. Pretty much the same thing. Almost the same thing. We have like vector stuff. Okay, 76 centimeters per second there. And then you wanna give the same value in terms of millimeters per second, right? So again, I'm gonna multiply it by 1. What do I mean by 1, right? So the thing is, I'm gonna multiply it by, I'm gonna have the centimeters as denominator because I want it to cancel. So 1 centimeter and 10 millimeters here. Again, 1 centimeter and 10 millimeter, are they equal? Yes, they are. So when I divide them, do I get 1? Yes, I do. So when I multiply 76 by 1, does anything change? No, it doesn't, right? So, yeah, you're gonna just have this, and specifically I did it centimeter is a denominator because I want centimeter to cancel, right? So it becomes 760 millimeters per second, right? So it's gonna be option C here, right? Yeah, that's right. And then the final question: the number of audiobooks in the library increased by this from last year to this year. See, number of in the last year, so it was n, and it increased by 131, so it becomes 1 plus because it have increased by again, right? It's not off, so it's not, the number of books is 131% of the previous year, right? it's increased by, so it becomes n plus n times the quantity 1 plus 131% over 100, or simply n 1.31, and then the number of audiobooks in the library this year is b times n. Okay, so b is 1.31, that's it, right? So, yeah, we have walked through the statistics, the problem solving and data analysis section now, right? The questions were not that challenging, if I'm being honest, except for one or two maybe, right? Statistics, it's always been the case, right? It's usually easy, right? You might have really difficult questions. I'm not saying statistics always easy, but just question banks and new questions, they were, right? And yeah, guys, we have one more video coming up, which is gonna be about geometry, right? I hope you guys learned something new in this lesson, and I hope you guys have improved your statistics, statistics, knowledge, expertise on the specifically statistics fields there, right? And yeah, that's gonna be it for today's video, guys. If you have found it useful, please leave a like, right? And please leave a comment, because it's gonna help this video go viral, right? As it's gonna help it even a little bit, right? And yeah, and at the same time, it does encourage me to make more videos when I see that people find it useful, right? And yeah, that's gonna be it. And see you guys. Bye bye everyone, and say bye bye to my friend Macron.ai, right? This panda basically symbolizes Macron.ai, right? And bye bye guys. Bye bye.